Okay, so in this video, we're going to talk about some quadratic functions characteristics. You've done a lot of this already previously in your Algebra 2 classes. We are going to revisit some of it and then go in a little more depth from the pre-calculus sort of end of it. Before I move on to what we're the actual content here, I want you to take a look at your know, understand, do list. I've got a copy of it here. Where we are going to focus in the next couple minutes is just mostly on the knowing stuff. We're going to talk about some definitions. We're going to look at some forms and some content there. Not so much in the do section, but we're really going to start building this piece here, understanding those forms. Just like with our linear equations, each form has its pros and its cons, advantages and disadvantages, and the same thing is true for quadratics. If you only know one form, you are going to create more work for yourself and sometimes be quite limited. So we want to become masters of all the different forms. All right, so the first thing is going to be the definition of what a quadratic function is. A function f is a quadratic function if it can be written in the form y equals a x squared plus bx plus c, where a, b, and c are any real numbers. Positive, negative, big, small, radicals, anything like that is fine. Fractions, no big deal. And one additional thing is that a cannot be 0. If a was 0, then we would start with a 0x squared. 0 times x squared is 0. And that quadratic term, that first piece we have in there, we call that the quadratic term because that's the term with the x squared. That quadratic term would disappear. And if that quadratic term disappears, it's no longer a quadratic. We are only left with the final two terms. And that would be a linear equation. So one more note on that stuff is that this function doesn't need to be in this form. It's just that it could be written in that form, meaning that whatever form it's in, if I did some algebraic manipulations, things like distributing, combining like terms, rearranging terms, etc., I could get it into this form. All right, so on and so forth. So that's what a quadratic, its basic definition is. Now, as far as some forms go, we have y equals a times x minus h squared plus k. Previously, in most cases, this is called vertex form. And it's called vertex form because the point h comma k is the vertex of the parabola. And this form you probably saw in Algebra 2. Probably didn't use it too much. But we're going to start using it more because it really uses the transformations that we've looked at previously this year. That this A gives us a vertical either stretch or compress. This H gives us a horizontal translation. And the K gives us a vertical translation. And so we can really start to implement the transformations that we looked at previously. But anyways, this is called vertex form. I do need to give you fair warning that in your textbook, in the textbook we are using, our text refers to this as standard form. It is unusual. I'll do my best to keep reminding you, but if you're doing your homework, you're working out of the text, you're reading the text, it is called standard form. This next one below here, and I'll just scroll up here, it can be called factored form, and it can also be called intercept form. Both are acceptable depending on the interpretation. We would call it factored form because we have two factors, two things being multiplied together, x minus m times x minus n. And so those are called factors. It is also called intercept form because m and n are the x-intercepts. A little bit tricky here because with linear equations, slope-intercept form, the intercept refers to the y-intercept. For quadratics, intercept form refers to the x-intercepts. Be careful for that. One other point of emphasis to watch out for is that we need to pull and factor out the a so that the leading coefficient on the x's inside the factors are both 1. So you need to take care of that ahead of time. So two forms there, vertex form, factored form. Hopefully we've seen them before, in addition to our definition form, ax squared plus bx plus c. So that gives us three forms that we are responsible for. Regardless of the form, we initially need to be able to find the zeros, which we call x-intercepts. We need to be able to find the y-intercepts, and we need to be able to find the vertex. And that vertex, depending on the direction of the parabola, can be called a maximum or a minimum. If the parabola opens down, then the vertex is going to be a maximum. If the parabola opens up, then that vertex would be a minimum. And that maximum or minimum refers to the maximum value of the output or the minimum value of the output. So here we're talking y-coordinates. And we'll get into that in a little more detail. So on the next couple of slides, I'm going to talk about these items as well as how to find them for each particular form here. And I'm going to try to get through it a little bit on the quick side. So when we have our definition form here, what is given to us is that the y-intercept is c. The reason for that is a y-intercept has an x-coordinate of 0. So if I wanted to find f of 0, I'd have a times 0 squared plus b times 0 plus c, which would give me 0 plus 0 plus c, which is c. So it doesn't matter what c is. If I'm trying to find the y-intercept for this particular form, I'm always going to get the value of c. So I don't even have to calculate it. For the other values, it can be a little bit trickier. So that information is given to us. What would we have to calculate and find ourselves? We would have to find the x-intercept, and we would find the x-intercept by setting y equal to 0 and then solving. It's just pretty standard stuff. And remember here when I say set y equal to 0, another way of saying that is saying f of x equal to 0. Remember that f of 0 is not the same as f of x equals 0. The first case is put 0 in for x. The second case is what x do I need to get out of 0? So just a little notation there. Pay attention to the details. They can be tricky. So as our x-intercepts, we would also have to be able to find the vertex ourselves. And recall from Algebra 2, the vertex has an x-coordinate of negative b over 2a. And then you would use the x-coordinate to find the y-coordinate of the vertex. The vertex is a point. You need two coordinates. An x-coordinate you calculate from negative b over 2a, and you would use that x-coordinate to find the y-coordinate. So of the three things that we want to find, x-intercepts, y-intercepts, and the vertex, this form gives us one of them directly, and we have to calculate two of them ourselves. And that's actually going to be a pattern through the three forms. That one of the things that we want to find will be given. The other two we will have to calculate. In vertex form, our given, the thing that we get for free without having to do any calculations, is the vertex. Shocking that in the vertex form we get the vertex for free. And the vertex is at the point h comma k. What are we going to have to find ourselves? Well, we're going to have to find the x-intercept, which is pretty standard. Set y equal to 0 and solve. And we're going to have to find the y-intercept, and that's going to be set x equal to 0 and solve your way through. And that's pretty standard general, technique regardless. There's nothing fancy there. To consider that to be new material, I think would be incorrect. But one given, one of the three important pieces of information was given to us. The other two we have to calculate. It's just, a different piece of given from the previous form. The third form for the intercepts form, that factored form there, the given are going to be the x-intercepts, and those are going to be m and n, and if you want to call it m comma 0 and n comma 0. So you get it for free. Don't have to calculate it. Don't have to worry about it. You just read the equation. You get it right there for free. But once again, we're going to have to find a couple of things. We have our x-intercepts. We're going to need to find the vertex. The vertex, because our parabola has symmetry, its x-coordinate will be halfway between the x-intercepts. And that's because we have symmetry there. And then, like always, we would use the x-coordinate to find the y-coordinate. And that is very similar to what we saw 2 slides ago for the initial form, the ax squared plus bx plus c, that we're going to, once we find the x-coordinate, we simply use it to get the y-coordinate. So those are our x-intercepts, our vertex. We're also going to need our y-intercepts. And general technique here, nothing fancy, nothing new. We are going to set x equal to 0 and solve through. All right, so that covers the forms, their names, what the pieces of information within the forms are, what within each form is given to us, and what form within each formula we have to calculate ourselves, the advantages and disadvantages. When you come into class, we will take care of working through a few examples and having you work through some of them yourselves as well. I hope you enjoyed this. I hope it was helpful. And remember, you can always go back and watch it again.